what do we got? What's f of 3? 5? Got a couple 5s. Anybody get anything different? So remember that f of x is just notation that tells us we have a function f and the variable in it is x. And then when we're asked for f of 3, all you have to do is wherever that x was, go in and replace it with a 3. Copy everything around it. And then, in this case, it's simplify, evaluate. We have 9 minus 4 gives us 5. Any questions? So what we're going to do today to finish up 8.2 is actually use function notation to get values from graphs. Go the other way. Here we go. So that's kind of our straightforward function notation. Now we're going to use a graph and we're going to find values for our function. So here's this graph, and this graph is f of x. And we want to find each of the indicated values. So the first thing to always do when you're asked one of these questions is determine if you're given x or if you're given y. And what I find the easiest thing to do from there is to look at your graph, go on your x or y axis depending on if you have x or y, and draw a point of where that is on your graph so you can find the corresponding value. So in A, we want to find f of 2 using this graph. Is this 2 represent an x or a y? If you think about our function notation, what's in the parentheses? X. We're looking at our functions are f of x. So that means this 2 right here is an x value. So I want to go to my graph on my x axis, go over to 2, and find where that hits the graph. So I'm over an x value of 2. I have a point right here on my graph that has an x value of 2. If I label this point, it's the point 2. My x value is 2. And the y value there is negative 4. Which means when the x value is 2, the point on my graph has a y value of negative 4. What's in the parentheses there is always x, and then what it equals is always the corresponding y value. So if I look at B, I want to find f of negative 4. So if I have the number in the parentheses, we know it's x because our function notation is f of x. So I go to my graph. I go to where x is negative 4, and this time I've got to go up to find my graph, which is right here. There's a point on my graph that has an x value of negative 4. And what we're really looking for is what the corresponding y value is at that point. So the y value at that point is positive 4. So that means f of negative 4 equals positive 4. It's just your x and then your y. So the same thing for C, f of negative 1. Negative 1 is our x value, so we're going to go to our graph and find a point that has, or points if it exists, an x value of negative 1, so go back to negative 1 on my x-axis, which happens to be right on my graph. And this point is negative 1, and I go up 0, so the corresponding y value then is 0. So if you're given the number in parentheses, you have x. What you're doing is you're going to your graph and you're looking for what y value it corresponds with. Questions? Then for D, for what values of x is f of x equal to 4? So is the 4 now x or y? Y. Then now it's y. So notice it asks you for what values of x. We don't know x. For what values of x? If you have the number on the right side, it's still y. What we're looking for, what the question asks, is what values of x have a y value of 4. So we've got to switch axes now. So last time we went left and right, found our number. Now we've got to go to our y-axis, and I want to find all values of x which have a y value of positive 4. So who can give me a point that has a y value of positive 4? What's the x value there? So my y-axis, positive 4. What's the x value at that point? 0. But notice the y value is 4, which is what my question wants. So I know that I have x equals 0. Are there any other points on that graph that have a y value of 4? I got some no's, got some yeses. Y value of 4. That's what we're looking for. We know we have y equals 4. We need to see if we can find points with y values of 4. So Christy, what's another point with a y value of 4? Negative 4, 4. Well, we actually even have that one labeled already. Look, we had that one from a previous question by chance. It's got a y value of 4, which is what this question asks. So there's another corresponding x value, negative 4. Are there any other points on this graph that have a y value of 4? Yeah, positive 4, 4. So notice the way that the question was written. In the previous ones, it just said f of 2 equals. But here it says what value or values. So there can be more than one solution because all of these 3 points across the top here have a y value of 4. So when you're given the x value, you're always looking up and down. When you're given the y value, you're looking left to right. And it's possible to have more. It's really possible in both cases to have more than one. But for us, it's really the second question we're going to see. So for E, for what value or values of x is f of x equal to negative 4 now? So am I given the x value or the y value? The y value. It asks you to find the x value, so we have to have the y value. So how many points on this graph have a y value of negative 4? How many points on this graph are going to have a y value of negative 4? 2. Because if we go down to negative 4, again, when you have the y, you're looking horizontally, left and right. Well, we have one labeled. It's out there. The other one, it's right here. There's 2 points on that graph that have a y value of negative 4. And what we want to know is what are the x values in those points. So we have x is equal to negative 2, positive 2. I will let you know, I believe this was one of the questions that was on the final exam last year. I don't know where it is this year. They change it every year. But any questions? Any questions just on our function notation? Expect to see from a graph and just function notation like that, like the problem we started class with. From your homework. But expect to see that on your drill next time. Part of your drill will have your function notation. Good. All right, 8.3. We're going to talk more about domain. And we're also going to talk about the algebra of functions. Which the algebra of functions, the questions look difficult. It's the same stuff we did the first and second day of class. So the only really new topic here is find the domain of functions. Now, last time we talked about domain from sets of points, and we talked about domain using a graph. So now we're going to talk about domain looking at a function. You're just going to have the function there. So we need to know about interval notation, which we actually did last time. So parentheses indicate that the endpoints are not included. So if you remember from the graphs, we looked at like the open circles. We said you're not including those points. We use parentheses. What always gets parentheses? Regardless. Infinity. So particularly if you have, we'll just do our example, negative infinity to positive infinity, it's going to use parentheses. This is another way of saying all real numbers. And then in this particular section, we actually aren't going to use the square brackets like we did on the graphs. But if you wanted to include your endpoints, like if you wanted to say go from 1 up to 10, including 1 and 10, you would use the square brackets. Now, not to be confused, that's not the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That includes like 1.1, 1.11, 1.1111. That's every number from 1 to 10. So this shows us our spans of numbers. Last time when we looked at the points, how do we show that it's just a discrete set of numbers? It's this number, this number, this number. What is our notation when we have, the squiggles. So when we're looking at include very particular numbers, we use the squiggly brackets, the set notation. But when we're looking at a span of numbers, that's when you use the parentheses and the brackets. So for us, the sets, the squiggles, are if you have just a set of numbers, graphs, and what we're going to do today, you're going to use that span of numbers. So to find domain, here's your little guy here. I divided by 0. I'm not sure why this person put a pirate head coming through the hole, but the house imploded. And you're going to see Unit 2 starts with a city imploding. You can't divide by 0. I used to start the class with saying the number one rule of this class is you can't divide by 0. Our functions are undefined if you divide by 0. So what we have to do in this section, we're getting into our rationals now, which are fractions, is we're going to look for trouble areas. And there's a couple of trouble areas. The first is when the denominator is 0. Now, it's only going to be 0 if it has a variable in it, or if a square root is negative. So we're actually going to come back to this idea in Unit 3. But for now, our trouble area is the denominator can't be 0. Denominator can't be 0. So we need to solve and find when any of our denominators are 0, and then we're going to have to set up intervals that essentially skip that number. And I'll show you with a number line how we can set up those intervals. If there are no undefined values, the domain is negative infinity to positive infinity. So if we don't have a denominator with a variable, any number will work. If we don't have a square root, any number will work. For us, it's just a fraction. So no dividing by 0. So your directions are going to say find the domain, write using interval notation. So again, it's domain, which now we've seen from 3 different things. So when I look at this and it says domain, again, we've seen domain applied to 3 different things. How do I know what to do? When I look at it, I see that it is a fraction. And when it is a fraction, I have a trouble spot. So it is a fraction, which means the denominator can't be 0. Say can't equal 0. So when you're looking for a domain, you're looking for those trouble spots, which for this problem is the fact that it's a fraction, the denominator can't be 0. So I need to find what value of x makes the denominator 0. When we're talking about domain, we never care about the numerator. Numerators don't affect us. So what number could I plug in for x that would make that denominator 0? Negative 7, because negative 7 plus 7 equals 0. Now the way you actually solve for that is you just take the denominator and you set it equal to 0. And you solve whatever equation you have. So for us, it's going to be subtract 7 from both sides. So we know that if x equals negative 7, then the denominator is 0. That's why we did that. We set it equal to 0 to find what value makes the whole fraction undefined. But I don't want the denominator to ever be 0. Which values, I guess you kind of know, which values go in our domain, x values or y values? X values. Domain's always x values. So I want to use an interval to say every x value, so let's look at this on a number line. I want every x value, I can't get my negative on there, let's try this. That's all of our numbers, negative infinity to positive infinity. I want every one of those included in my domain except negative 7. We've got to cut negative 7 out. And we're going to do that using intervals. So there's 2 intervals I need. I need the interval that goes up to negative 7, but it doesn't include it because we don't want it. It's the only number in the whole number line we don't want. And then I'm going to need another interval that takes care of the other side. And again, we're trying to create that hole there at negative 7. We're not including it because we don't want it. It would make the denominator 0 and the whole problem undefined. So if I look at this blue interval, what number does this blue interval start at? Negative infinity. And what number does this blue interval go up until? -7. But do we want to include -7? No. So what do I put around the -7? A parenthesis or a square bracket? Which one doesn't include it? Parenthesis. This is why we have that notation. Include it, don't include it. We don't want -7. It's the only value we don't want. So I'm going to put a parenthesis around the -7. So this says every number for x from -infinity up to but not including -7 will make this defined. But that only takes care of half of it. Everything in red here works as well. So there's a couple of options for what goes between the two intervals. Your book just writes the word or. But we have a math symbol for that, which is a little bit less writing. And it's a big U. So you do one or the other. You wouldn't put both. But if you look in your book, they're going to write out the word or. The math symbol for that is the big U. But you do have to have something between your two intervals because there's a difference between and or mathematically. We're only dealing with or. So now I need to represent what I colored up here in red. So what value does this start at? It's a little tricky. What value does this start at? Still starts at -7. So we're picking up again at -7, but am I including it? No. So it's still a parenthesis. So even though both intervals have that -7, we're not actually including it. And then where's the red side going to? Positive infinity. And again, infinity always gets your parentheses. So this right here, this is your interval notation. You don't have to draw the number line. People ask that all the time. I just use that as a tool to visualize where our intervals are. But the parentheses with the infinities, the or, that's your actual interval notation. That's what your answer should look like. Any questions so far? All right, let's look at B. F of x equals 4x minus 18. So we're asked for the domain. So when you're asked for a domain and you're given a function, what you're looking for are trouble areas. We're trying to find numbers that we can't include. So if I look at B, I see 4x minus 18. So what was my trouble area in the first one? Huh? The fraction. I had a fraction. It had a denominator with a variable, so we had a potential there. Do I have a fraction here? No. Okay, the only other trouble area we have in this class, I guess we have logs. They're in there too eventually. But square roots, which we're not even getting to until Unit 3. Do I have a square root there? No. So I don't have any denominator to worry about. I don't have any radical to worry about. So I don't have any numbers that are going to give me trouble. So the only two places for us for now that you're going to worry about are if you have a fraction, not a fraction. If I have a square root, not a square root. So if I'm thinking again in terms of my number line, so if I'm saying there's no parts of this that are going to give me trouble, that are going to make it undefined, that are going to make it not real, what do you think my interval is? That would say only 0. My question is just, can I substitute 1 into this and get back an answer? Yeah, I could do 4 times 1 minus 18. So there's more numbers than just 0. So think about, up here we said cut out -7. And then we could set up our intervals. Down here, I said I'm not cutting anything out. So where does my interval start? -infinity. Where does my interval go up to? Positive infinity. I don't have any speed bumps in the way. I just go whole number line. So this problem is actually easier than the other one. All of the numbers work because there's no fraction and there's no square root. So that means any value will work for x. Any value I substitute in, I can get back an answer. The problem up here is if I substitute -7 in, this becomes undefined. I can't get an answer. In C, am I going to have any speed bumps? Am I going to have to cut anything out? Yes. What about that indicates to me that there's a problem, that I'd have to find a value that I have to cut out? It's fraction. Now, fractions in general do not necessarily mean you have to cut out a value. It has to be a fraction that has a variable in the denominator. If the denominator was like 2, it's not going to give me any trouble because it couldn't be 0. But it's when this denominator has a variable, that's when I have trouble. So to see what value I'm going to cut out, I take the denominator and I see when it equals 0. That's the problem in these domain problems, is when the denominator equals 0. So I set the denominator equals 0 and I solve it, and that tells me what number creates a problem, what number I can't have. So in this particular problem, if x equals 6, we say it above, the denominator is 0. And that's our issue. If x equals 6, the denominator is 0, which means the whole problem is undefined. So we want to say to whoever you're talking to about your math homework, I need every number except 6. 6 doesn't work in this problem. Any other number you choose for x will work, but not 6. So if you like a visual, I like a visual. Let's set up our number line. And in this problem we said we've got to cut something out. All numbers don't work here. We can't have the number 6. Doesn't work in this problem. Makes my denominator 0. It's undefined. So I want to tell the person next to me every number up to 6, and every number after 6 is okay, just not 6. And I need to do that using intervals. It says in the directions, use interval notation. So where's my first interval starting? Negative infinity, and it goes up to, oops, I just wrote this. Negative 6. Okay, let's try this again. Negative infinity up to 6. Am I including 6? No, so you got to use the parenthesis. For these particular problems, you'll be using all parentheses. And you can't leave me hanging. You can't just put two intervals next to each other. You either write out the word or you can use the U. It's our math symbol that means or. And then your next interval. And where's the next interval start? 6. But not quite on 6, just after 6, so we use the parenthesis. And then that one goes up to infinity. And that right there with the parentheses, with the U or the word or, that is your interval notation. That's what the answer should look like. Any questions? So again, we have 3 different types of domain now. If you're asked for domain from a set of points, you use the squiggly brackets because it's a set. If you're asked for domain from a graph, you have to look at your parentheses, brackets, your x's and y's. You also do range. If you're looking for domain from a function, what you're focused on here is that trouble area. If you have a fraction and the denominator's got a variable, you got to cut something out of the x's. Questions? And this is actually going to be the same thing we start Unit 2 with on Wednesday, finding variables that make fractions undefined, or values. All right, so the last topic that's going to be on your Unit 1 test, so this is the last thing that will possibly be on your test, is the algebra of functions. Now, it looks difficult. So you're going to be asked to find, for example, f plus g of x, f minus g of x, f times g of x, and f divided by g of x. My only advice really is always use parentheses. Whenever you substitute a function, use parentheses. But don't let this notation have you get these problems wrong. These should be easy problems. This is the first and second day of class. The only difference is you have to set up the problem for yourself before you simplify. They're just simplified problems. They're simplified problems like the first and second day. You're going to add 2 functions. You're going to subtract them, multiply them. We don't even divide them. You'll see how easy that kind of is. So don't overthink the notation. What happens is people add f and g and then multiply it by x. That's not what it's saying. This f plus g of x, for example. Oops. That's the wrong place. F plus g of x just says x is the variable. It does not mean multiplied. So don't throw an extra x on the end. That's my biggest advice. That's really where people get these wrong. It's just notation. It just tells you that x is the variable. It doesn't mean multiply everything by x. So what's going to happen in these problems is you're going to be given some functions. So here we have f of x equals 7x plus 4, and g of x equals 5x minus 2. We want to find f plus g of x, f minus g of x, f times g of x, and f divided by g of x. So let's just start with the first one. Let's find f plus g of x, which is really just f of x plus g of x. Think about it like it's just the function f plus g. It's not times x. Don't throw an extra x on there. So all you want to do is copy your functions. F of x is 7x plus 4. I want to add to that g of x, which is 5x minus 2. And we did that problem on the first day of class. Maybe not that exact problem, but problems just like that on the first day of class. The only difference here is we're stepping it up and making you write the problem first. You have to write this plus this before you simplify. So now, first day of class, when I add functions, all I have to do is combine their like terms. So I can combine the 7x and the 4 and the negative 2. So I just get 12x plus 2. So it's just an addition problem of the two functions. You just had to set it up first. Combine your like terms. The next thing you want to find is f minus g of x, which is just take your function f and subtract your function g. Again, the parentheses in the x is just notation, telling us that's the variable. Use parentheses. Can't stress this enough. Didn't matter on the first one, it will matter here. So our setup is identical to the first problem, except the sign is not plus. We were asked to subtract. So I set up my function f, which was given to me, minus my function g. How do we yeah. Yes. Yes. Yep. So this goes back first day of class where we subtracted polynomials, and what Anna just said was see the negative in front of parentheses, and this is why you got to put those parentheses in there. You have to distribute it. Now, whether or not you just go through and change all the signs, if that's how you like to do it, or if you like to put in the negative 1 and go in and switch the signs, however it happens, just make sure it happens. So I have 7x plus 4 minus 5x plus 2. And that concept there, first day of class. And then combine your like terms again. And we have 2x plus 6. And don't factor these. We're not factoring in Chapter 8. Simplify. Chapter 5 and Chapter 8 is just simplifying. Any questions so far? Because again, the notation itself looks complicated, but it's what we did on the first day so far, just adding, subtracting. You just have to set the problem up for yourself. Now the third part of this is looking for f times g of x. What do you think we need to do with those two functions? Someone said it quietly. Multiply them. Use parentheses. So this is just saying take f and multiply it by g. Don't put an extra x on there. Just f times g. So if I put my f of x in parentheses and I multiply it by my g of x, What type of problem is this? I have a binomial multiplied by another binomial. How do I multiply those? What's that process called? Foiling. It is a type of distributing, but this is really a FOIL problem. So my first, outer, inner, last. So I have 35x squared minus 14x plus 20x minus 8. And if I combine my like terms, 35x squared plus 6x minus 8. Do not take time to factor that back out. If you take time to factor back out, guess what? You're going to get 7x plus 4, 5x minus 2. What we just multiplied together. So FOIL, combine your like terms. That's it for your multiply problems. And the only one we haven't looked at so far in terms of this class is f divided by g of x, which again, think about it just as f divided by g. Pull this up a little bit. And this is the easiest one, right? F of x, which is 7x plus 4 over 5x minus 2. Right, is a fraction. Fraction shows division. Trust me that you can't simplify that, and we're done. We'll learn in Unit 2 how you might simplify that. You can't, this particular problem, but we'll learn how to simplify fractions like that in Unit 2. So that's the easiest one. Just one over the other. I guess you can mess up the order. You can put the extra x on there. Don't put the extra x on there. Cannot stress that enough. These should be easier problems. These should be your reprieve from all those factoring problems. Questions? The other homework question you're going to see is, it's going to ask you, the only other thing you'll see for this, it'll ask you to set this up and then to tell you the domain for this. Where would you find the domain of this particular problem? It's the first thing we did today. Second thing we did today. What's the trouble area in this problem? It's a fraction. Denominator can't be 0. So your homework is going to combine these two concepts. It's going to make you put the fraction together, and then it's going to go back and ask you find the domain. So just be aware when you go to your homework, it's going to combine the two concepts. It's not going to always give you the fraction. It's going to ask you to write the fraction, and then it's going to ask you for the domain. Which I said, I think I put on your guided notes as a hint to look at number 1 through 7. I think it's on, I think that question is 49. So just be aware your ideas can get mixed up. So B, we want to find f plus g of x and f plus g of 2. And we've got our two functions there, f of x and g of x. So it's, again, asking for two separate things. Two separate things. The first thing it wants is it wants you to find f plus g of x. So that means just take whatever your f of x is and add to it your g of x. So I'm going to take x plus 3 and add to it 3x minus 1. Just whatever f was, whatever g was. We're going to add those together. I can combine my like terms. No special rules here because it was addition. So I get 4x plus 2. So that was one question. Completely separate question. Find f plus g of 2. Now, it doesn't necessarily have to be unrelated, but the way I would go about these problems where you're given a value is evaluate your functions separately. So I want to find that f function when x is 2, and then I'm going to find my g function when x is 2, and just add the two answers together. That's the easiest way to do this problem because you don't necessarily always have the first piece. So first thing I want to do is find f of 2. So I'm going to go to my f of x function, and I'm going to replace the x with 2. So I have 2 plus 3, which tells me f of 2 is 5. And then I'm going to do the same thing with the other function, with the same value. I'm going to look at g of 2. So I'm going to substitute 2 in for my x. 3 times 2 minus 1. Order of operations, 6 minus 1. That also happens to be 5. And then what did the original problem want me to do with these two values? Add them together. So to get my answer, I just take f of 2, which was 5, add to a g of 2, which happens to be 5. They're not always the same. And the answer to this problem is just the number 10. Now, you could have also gotten that using your combined function from number 1. So we know, this is just a separate way to do this problem. We know that f plus g of x from number 1 is 4x plus 2. So if I want f plus g of 2, all I have to do is go into f of g of x and replace the x with 2. Four times 2 is 8, plus 2 still gives me the answer, which is 10. The reason I don't really recommend this way right here is you don't always have to find the generic combined function first. So if your problem, like this next problem, just wants f minus g of 4, I wouldn't waste your time finding f minus g of x, then substituting in 4. You've got more places to make error, especially if it's multiplication. It's going to take a lot more time. So if you have a value that you need, look at each function separately, and then just take the two answers you get and then add them, subtract them, multiply them, whatever you're asked to do based on your functions. But two different ways that you could get that same answer of 10. Questions? So you see C says find f minus g of 4. It doesn't ask you for f minus g of x first, so I would not waste your test time, your homework time, whatever, finding it first. I would just realize that, okay, I need to find f of 4. I need to find g of 4. Take those two answers and subtract them. That's what that problem's asking for. So we have f of x and we have g of x. We're going to go into each one separately and substitute in our 4. So 3 times 4 squared plus 2 times 4 minus 1. Just looking at f of 4. Order of operations, what do I have to do first? Exponents. Got to take care of that 4 squared. Don't multiply the 3. So I have 16. So 3 times 16 is 8 minus 1. Yeah, 48 plus 8 minus 1. So f of 4 is 55, hopefully. Any questions just on that, the finding f of 4, substituting the values in our function, or if I made a mistake, that's the time to let me know. So now I need to find g of 4. So I'm going to just go into the other function, replace the x with a 4, and evaluate. So 4 times 4 is 16, minus 5 gives me 11. So I found my two functions separately. What do I need to do with those two numbers? What does this problem want me to do with those two answers? Subtract them. So f minus g of 4. So just take 55, subtract from it 11, and you get the answer to the problem. So all that work, your answer, 44. Questions? All right, one more. I'm probably going to just have time to set these up, and I could trust that you could hopefully simplify them. Setting them up is the only place people get these wrong, usually. They don't understand the notation. They can't set them up, so they can't simplify them. So we're given two functions again. These are actually a little bit simpler. We have 5x and then 2x plus 1. And this wants you to do all 4 different combinations. So first one is to add them. It's first function plus the second function. Next, to subtract them, again, use those parentheses. First function minus the second function. Next, to multiply them, just put them both in parentheses and write them next to each other. And then last, division is actually the easiest one. Just write f of x over g of x. Trust me that you can't simplify it for now, and you're done. So your answers, when you do simplify, so you have them 7x plus 1. Be careful on those subtraction problems that you remember to distribute your negative sign, to change all those signs. That's another place where I find myself taking off a lot. 3x minus 1. This one's just a nice distribute on that multiply. Like I said, on the division, you just set it up as a fraction. So just to round it out, to bring us back to the first part of class, because I think this is number 49. What is the domain for numbers 1, 2, and 3? What is the domain for numbers 1, 2, and 3? Negative infinity to positive infinity. So you're gonna, on your homework, you're going to have to put these two ideas together. So if you don't have a fraction, your domain is just negative infinity to positive infinity. It's on this last one where you'd have to set the denominator equal to 0, cut out the number, that sort of thing. So I think it's number 49 on your homework. It puts the two ideas there together.